Welcome back again. Here we are standing with Matthias Schultz again and talk about the ISO standard. And today we're going to talk about ISO 14120, about guards.
Yes.
Can you, what is this standard for? Can you tell me?
Well, it's a standard on mechanical guards actually, so not electronic systems, on so-called fixed and movable guards.
Yeah.
It's the follow-up standard for EN 953, which we had before. And it brings in a few new ideas, construction principles, design rules for this type of guard.
Perfect. So what do you think is the most important about this rule?
Yeah, the most important to me is the selection guidelines on when to use which type of guard. For instance, fixed guards are in discussion very often because fixed guards you can remove and then the machine can run nonetheless, because on a fixed guard you have screws fixings, but you don't have a switch normally. So there should be limitations for their use. While the movable guards always have what we call interlocking, so they have a switch. The machine will know where the guard is it closed or is it open, and the hazard cannot be present while the door is open or the cover is open that is being detected by that switch. So there's a marked difference when to use which. And we have two basic questions that we need to answer. Number one, why do people want to go in? Why do they want to remove the guard? So you can use fixed guard only if it's off normal operation. So if the intervention is for maintenance or to fix some bigger problem.
Changing tool or a breakdown on the machine,
Because in these situations, normally you will stop the machine and probably even shut it down or tag it out and log it out for some time so that you can do that work safely and then remove the guard. While the movable guard can be used also in normal operation. That's the first question you would have to answer. And the second question is how long and how often will you remove it? Especially how often is very important. If you remove a fixed guard very often, even for maintenance, then it's quite likely that people will not fit it. And then
it's a risk, you
have this big panel leaning against the wall, and then the safety officer comes by and says, hey, take this away, one can stumble across it, and then your guard's gone. That would be very dangerous. So the new standard sets a limit on no more than once per week, which I think is quite realistic and reasonable too.
If you need to open more than once a week, you have to put a door with a security switch.
And you should have a switch. So that the machine cannot run while the guard has been removed. So this is very important. And of course there's other guidelines on selecting the right type of guard. Some want power operated guards because they're very big. And then you need to think about not crushing hands in the closing guards.
Of course,
Many details concerning that in there. And a second important point is stability of guards. And that has really been added before, because before we did not have any information on this really in this type of standard. And now we have information on minimum stability from outside, and we have ideas about crash tests in the informative annexes.
If you talk about stability and crash tests, what is your point of that?
Yeah, well, we see lots of videos now on the internet of crash tests. And of course it makes sense to perform crash testing. Axelent has also done so, not only once, several times, because you want to know what really your fence can withstand. But to me, a video published in the internet doesn't say much, because you don't know what the exact test situation was, what was the bolting like on the floor, and of course they often name the weight that they used, but real applications are so very different often from such a test setup. So to me, it does not prove very much to have such videos. Of course we do testing and we tape them, but to publish them, I don't think it makes very much sense.
I always thought that the protection of the fence was to protect me and you, or the people that works in a production facility, to not walk in or run into a hazard by mistake, because that is what I would say normally happens. Even if you have a light beam, people walk in because you don't see it, the light beams, but you walk into a danger zone and a hazard. And for me, over all the years I've been working, I've never seen anyone running through the fence. Doesn't matter if it's our fence or somebody else's fence. It's very difficult to run through a fence. And I mean, the crash head is such a load, and it feels like it's the opposite. They want to protect the machine for running out. Is that correct? Or is that following the norms, really?
Actually, that may be the consideration. First of all, I would also say that the main idea of the fence is to keep the person out and not the hazard in. We are not building cages to protect people from lions. No. When you remember our first chart.
Yeah, I know.
We control the machine, and we can control the machine inside the fence without the fence. So its motion range should be limited. Yeah. That is also true of robots. You can limit their motion range mechanically by putting end stops, and you can limit their motion range by software. You can limit their motion range by limit switches, and these should be used. Safety control systems, no? Where you can program a range in front of the fence, where the robot has to slow down so it won't hit it. So it doesn't really make sense to build fences to keep robots in, especially the large, high payload, fast robots. It's virtually impossible to build a fence that will hold back a robot running haywire at 3,000 or 4,000 joules. So we have limit values that were targeted at somebody falling against the fence from outside. You can stumble in an aisle and fall into the fence or against the fence element, and then of course you don't want to be inside the machine. For that you need, as the standard says, 135 joules only, while what we are seeing testing is now between 12 and 1600, 2000 joules. This is more targeted at keeping stray robots in, or keeping material in that is lost by the machine. But to me, the fence is the last solution that you want to do that.
I totally agree on that. It feels like it's like the easy way out to get the fence to protect the machine.
Yes. It would be better to make grippers that hold onto materials safely, and to devise the control system and the whole process setup in a way that this type of hazard will not happen. Because if you want to fence in a large area safely so that no material can be thrown out over the fence or destroy the fence because of collision, this will be very, very costly, very difficult. Our standard materials will withstand reasonable loads. This can be proven by the test documents, which give details, which is much better give a lot of details of how the test was performed, what were the values that were used, the weights and so on, and especially also the fixings on the floor, which is a critical point, instead of just giving a movie that doesn't really say nothing.
If you talk about how you bolt it in the floor, there you can see a big difference from if you're different countries, how good the concrete is, or what type of flooring it is, and I totally agree. That is also, it doesn't really help if the fence is super good if the floor is really, really, really bad. So
definitely. So that's what 14120 is all about.
Okay.
Giving us test strategies and limit values for crashing from outside. For crash from inside, they haven't even defined a limit value.
No. Perfect. Thank you so much, Matthias. And stay tuned at Axelent TV. We'll be soon back with more norms.
Yes.